Oh god, stoichiometry. This lesson is probably one of the most crucial things to learn, and for me, one of the most tedious. Stoichiometry, unfortunately, will tie into many other topics as well. So, let's get down to it.
Hi guys, my name is Natasha and I will be helping Brian today inform you on the basics of stoichiometry. Personally, stoichiometry for me was the toughest part of AP chemistry, and that is why I want to help anyone who is learning it in any way I can. Brian will start off by telling you about the different types of stoichiometry problems. There are general stoichiometry problems, hydrate problems, and solution stoichiometry problems. Stoichiometry is basically the math behind chemistry and is used to figure out amounts of elements used in a chemical reaction. We can figure out how much of a compound is needed to produce a certain amount of product. Stoichiometry is based on elements behaving in predictable ways. The law of conservation of mass and the law of definite proportions are physics laws that stoichiometry is based off of. So, since you guys are able to use calculators this year, the may not be as difficult than they were this year. Now, I'll leave it to Brian to enlighten your eager minds.
But now, what is stoichiometry? Stoichiometry is the area of study that examines the quantities of substances consumed and produced in a chemical reaction. Let's say we are out camping with the family and homies, and like in any camping trip, there will be a grill cooking up some nice grub and steak. Of course, we all love our Mother Earth, and a lot of us are concerned about pollution. Everyone knows that charcoal produces CO2 into the air, and we know that that's not healthy for our Mother Earth. Well, is there a way to find out how much pollution or CO2 you're emitting into the atmosphere?
I think there is, Brian.
Well, of course. That's why there is always stoichiometry. So now this is where stoichiometry kicks in. We should start off first by understanding what charcoal is. Well, the honest truth is, charcoal is just carbon. You see, charcoal is an allotrope of carbon. You see, carbon is of three physical states, which are charcoal, diamond, and graphite. All this happens due to the different number of electrons being shared. See, carbon has four electrons in its last shell, so it forms covalent bonds. But this is a totally different unit, which you don't need to know right now. So, anyways, back to the state. I mean, CO2 emissions. So, anyways, back to making this state. I mean, CO2 emissions. First, we must figure out the mass of charcoal. We can simply do this by measuring the amount of charcoals you have on a mass scale. You will then get the amount of grams. Okay, so this tells us how much charcoal we have. But now, we're going to add fire. So now, we add the fire. This is where a chemical reaction is actually going to start, bro. This is it right here. So as you can see, well, I actually can't see, but you can imagine that there's actually CO2 emitting from this piece of charcoal while it kills all the ants around. So now we have a chemical formula that reads C3H8 plus O2 then yields to CO2 plus H2O.
Hold up, Brian. Where did the H8 come from?
Well, you see, Natasha, I have no idea. What? Women. So now we have a chemical formula, C3H8O2 that yields to CO2 plus H2O. So the first thing you're going to want to think about is which element is reacting. Or in other words, which substance will run up first. So take a minute. Think about it. Which one is the limiting reactant? Alright, time's up. If you said fire, O2, then I have some bad news for you. But if you chose the charcoal, which is the C3H8, then I congratulate you for having some common sense. Now here comes in the calculations. You should all know by now what atomic numbers are. I emphasize the should. Otherwise, you may want to reconsider your placement in this class. So anyways, the atomic number of carbon is 12, the atomic mass of hydrogen is 1.01, and the atomic mass of oxygen is 16. Let's say we start off with 500 grams of C3H8. Now we'll have to convert these grams into moles so we can compare them to other elements. So we convert the moles to grams by dividing by the atomic number of charcoal. Alright. So now the atomic mass is 44.08. When you divide by these units, the grams will cancel each other out, which we will be left with the moles. And we get 11.343 moles of our charcoal. But now we're forgetting something. We have an equation, but an equation isn't very useful for us if it's unbalanced. So now our equation, as you can tell, is unbalanced. It has 3 C's on one side, 1 C on the other side. It has 3 O's on one side and 2 O's on the other side, and 8 H's here and 2 H's there. Okay, so let's balance this. It's simply just 1, 5, 3, 4. Now we can see that both sides have 3 carbons, both sides have 8 hydrogens, and both sides have 4 plus 6 is 10, 5 times 2 is 10 oxygens. Now that they're balanced, we can continue with our calculations. The next step, after we have these 11.343 moles of C3H8, we're going to have to convert them from C3H8 to CO2. We're going to do this by comparing moles again. So on the bottom we have, for every 1 mole of C3H8, we get 3 moles of CO2. This comes out to 34.029 moles of CO2. Continuing on, we can't really picture how much 34 moles is, so let's convert it into something that we actually know. So let's convert it into, liters. So for every 1 mole of CO2, we're going to get 22.4 liters of CO2. So this comes out to 762.25.
So now that you have a basic understanding of stoichiometry, go and use it.